Hello all, this is M. Sandeep Kumar and I welcome you back to my YouTube channel Math with Sandeep. So we are in the chapter of limits and already we have discussed limits at infinity in previous video. So this is a continuation of that particular video. So we will discuss more number of models in the topic of limits at infinity. Okay, fine. Let's start with our first question. If 0 less than a less than b, then they are asking us to find the limit n approaches infinity, a power n plus b power n whole power 1 by n. A very simple question, but what we are supposed to remember, that is important. What are we supposed to remember? In our previous classes, I have discussed that if proper fraction power infinity is 0 and improper fraction power infinity will be infinity. So this is what we have discussed in our previous videos. I am going to use that concept in this particular question and also in next questions. Okay, fine. So dear students, if you observe one thing, they told that 0 less than a less than b and they are asking us to find this limit now. Observe, they just told that a and b are positive and particularly a is less than b. So from this I can say that a divided by b is less than 1. What is the meaning of it? It means that a by b is positive and at the same time it is less than 1. So which means that a by b is going to be a proper fraction. And moreover n is approaching infinity, the power n is approaching infinity. So you do something and you create proper fraction power infinity so that the answer will become 0. So that is what we are supposed to do in this question. Observe a power n plus b power n is there and whole power 1 by n is there. You can take a power n common or you can take b power common. What I am going to do is I will take b power n common in these two terms. So why do we do that? You can understand this. So if I take b power n common in these two terms, so b power n comes outside and at the same time it takes power 1 by n. When it comes outside power 1 by n, it also takes power 1 by n. I took b power n common into, here I took b power n common na, so this becomes a power n divided by b power n plus 1 whole power 1 by n. So n and n gets cancelled and b is a constant independent of the limit. You can take it outside, b into limit n approaches infinity. So this becomes a by b whole power n plus 1 whole power 1 by n. Now dear students, observe that a by b is a proper fraction, correct or not? A by b is a proper fraction according to the condition given here and n is approaching infinity. So this is going to be what? Proper fraction power infinity whose value is what? 0. So this is going to be 0. So a by b whole power n becomes 0. It is b into 0 plus 1 whole power 1 by infinity. Obviously 0 plus 1 is 1. 1 power 0 will be 1. B into 1 and the answer is B. So dear students, the answer for this question is B. Once again, if I take b power n common in these two terms, I will get proper fraction power infinity. If I take a power n common in these two terms, I will get improper fraction power infinity. To avoid improper fraction power infinity and to get proper fraction power infinity, I have taken b power n common to get a by b. If I take a power n common, I will get b by a. B by a is improper fraction, that is not needed. So I have taken b power n common. Okay, now so the answer is B. We'll see it. We'll look at next question. So in our second question, again they told 0 is less than x less than y, obviously like in the previous question. So this is the condition given. They told us to find the limit of this particular function. Here also, if you understand, if you observe this condition, this means x by y is less than 1. So x by y is a proper fraction. Obviously x by y is greater than 0. Correct or not? Because if I divide with y, here, here and here, I will get this. Y is a positive number now, so inequalities did not change. Okay, what you are supposed to understand is that x by y is less than 1. X by y is between 0 and 1, which means x by y is a proper fraction. Here also you do something so that you will get x by y. Okay, now fine. What am I going to do is I'll divide the numerator and denominator with the highest power of y. Because I want y in the denominator, x in the numerator. Okay, now what is highest power of y in these two? Y power n plus 2 na. So divide numerator and denominator by y power n plus 2. So divide the numerator and denominator by y power n plus 2. What are we going to get then? limit n approaches infinity. So x power n plus 2 divided by y power n plus 2 plus y power n plus 2 divided by same y power n plus 2 whole divided by x power n divided by y power n plus 2 plus y power n divided by y power n plus 2. So dear students, if that is the case, in the next step, after simplification, this will become x by y whole power n plus 2 plus this is 1 whole divided by, you can understand that this is x power n divided by y, this becomes what, a power m plus n, a power m into a power n. So this becomes y power n into y square. The denominator will become what, y power n into y square. So x power n divided by y power n with denominator y square. So I can write as x by y whole power n. X power n by y power n is x by y whole power n. In the denominator we also have y square, and next plus here this can be written as what, y power n into y square. Correct or not? Y power n and y power n will get cancelled. I'll get 1 by y square. Okay dear students, as n approaches infinity, x by y power, as n approaches infinity, infinity plus 2 is also infinity. And x by y is what fraction? X by y is a proper fraction, and proper fraction power infinity is what, dear students? 0. Correct or not? So this becomes 0. Similarly this also becomes 0. What will get? I'll just since I have substituted n approaches infinity, this becomes 0 plus 1 divided by 0 into 1 by y square is also 0 plus 1 by y square. And therefore what is the answer, dear students? 1 divided by 1 by y square will become y square. That is the answer. Are you observing how we are using this concept of proper fraction power infinity? So therefore the answer for this question is what? Y square. This is equal to y square. So we'll go with next question. We can answer third question just like the previous question. So I'm just rushing up. What is the first step, dear students? I hope you will understand this. Just like the previous question, what I will do? Yes, we will divide the numerator and denominator with what? With what? There is 3 powers and there is 6 powers. With what I will divide the numerator and denominator? 6 powers. Is it 6 power n plus 1 or is it 6 power n? The highest power of 6 power n plus 1. So that is how we divide. Divide numerator and denominator by 6 power n plus 1. See, if I divide with 6 powers, I'll get proper fraction power infinity. And if I divide with 3 powers, I'll get improper fraction power infinity. We do not want improper fraction power infinity. We want proper fraction power infinity. Okay, now I'll divide numerator and denominator by 6 power n plus 1. So limit n approaches infinity. 4 into 3 power n plus 1 divided by 6 power n plus 1 minus 5 into 6 power n plus 1 divided by 6 power n plus 1 whole divided by 6 into 3 power n divided by 6 power n plus 1 plus 8 into 6 power n divided by 6 power n plus 1. I divided numerator and denominator with 6 power n plus 1. Correct or not? Next, as we have seen in the previous question, here also 4 into, this is 3 by 6 whole power n plus 1 minus 5 into, this 2 will get cancelled, you will get 1, 5 into 1, 5. And here dear students, 6 into, this is what, 6 power n plus 1 is 6 power n into 6, correct or not? So this 6 and this 6 will get cancelled. 3 power n by 6 power n is 3 by 6 whole power n. 3 by 6 whole power n. Okay now, then plus this is what, 6 power n into 6 power 1. 6 power n gets cancelled and you will get 8 divided by 6. 8 divided by 6. So dear students, as you see, 3 by 6 is a proper fraction. N approaches infinity. So n plus 1 also approaches infinity. Proper fraction power infinity is 0. Okay now, 3 by 6 is a proper fraction and its power n plus 1 is approaching infinity. Proper fraction power infinity is 0. So I get 4 into 0 minus 5 whole divided by, this is again 0 plus 8 by 6 is 4 by 3. So the power will be minus 5 and divided by 4 by 3 means into 3 by 4. The final answer is minus 15 by 4. This is the answer. Minus 15 by 4. So therefore limit n approaches infinity, this function is equal to minus 15 by 4. Okay, we'll go with next question. Dear students, an important note in GP. So you remember that sum of first n terms in GP, what is it? A plus AR square plus and so on plus A into R power n minus 1. You should have known these concepts already. These are the terms in GP whose sum is given. So Sn is equal to sum of first n terms in geometric progression, GP. Where R is equal to, second term divided by first term or third term divided by second term, whatever you want to take. The question is, what is limit n approaches infinity Sn? What is the meaning of it? If this n, the number of terms is approaching infinity, then what is sum of n terms? It is nothing but what? Sum of infinite terms. Correct or not? N approaches infinity. Na? So indirectly, what is sum of infinite terms in GP? That is the question. So there are two possibilities. If R is a proper fraction, the common ratio is a proper fraction, okay na, then what happens means you will get A plus AR square and so on infinity. Obviously what you will get, let us see first, okay na. First of all, let us try to find what is the answer when sum of infinite terms are taken. So we know that Sn is equal to A into R power n minus 1 divided by R minus 1, and since R is a proper fraction, instead of taking R power n minus 1 by R minus 1, we will take it as what? 1 minus R power n divided by 1 minus R, since R is a proper fraction. You have seen this. As n approaches infinity, dear students, limit n approaches infinity na. So what is this R power n? R is a proper fraction and power n is infinity. So proper fraction power infinity will be 0 na. So that means what? R power n will become how much? 0. So sum of infinite terms will be A into 1 minus 0 divided by 1 minus R. You will get A by 1 minus R. So that means what? Sum of infinite terms will be equal to A by 1 minus R. A by 1 minus R when? If R is a proper fraction between 0 and 1. And what if R is improper fraction? What if R is greater than 1? Again here two possible answers are there. If A is a negative number, and R is improper fraction, you will get negative plus negative plus negative plus negative, whose values will be increasing and so on up to infinity. So the answer will be minus infinity if A is negative and R is greater than 0. And the answer is plus infinity if A is positive and R is greater than 1. Of course, in both the cases, R is a improper fraction. If A is negative, you will get minus infinity. If A is positive, you will get plus infinity. Okay na? So in case if you need an example, just see here, let A is positive, 2 plus, and common ratio is greater than 1 na? Let the common ratio is 3. Okay na? What is second term? The common ratio is 3 and A is equal to 2 na. What is GP? Sum of the terms, infinite terms in GP, 2 plus A into R. So 2 into 3, 6. Again multiply common ratio to this, 18. Again multiply common ratio to this, 54. And so on infinity. It just takes common sense. 2 plus an increasing number 6 plus an increasing number 18 plus and so on up to infinity. What is the sum? Obviously the sum approaches infinity only. And what if A is negative? A is equal to minus 2 but still R is 3. R is improper fraction but A is negative. In that case the first term will be minus 2. Multiply common ratio to the first term, you will get next term minus 6. Multiply 3 again, you will get minus 18. Again multiply 3, you will get minus 54 and so on. Infinite terms. You are adding negative numbers up to infinity. What is the meaning of it? The answer will be minus infinity. Correct or not? So what I am trying to say is, sum of infinite terms in GP has three possible answers. If common ratio is a proper fraction between 0 and 1, then sum of infinite terms will be A by 1 minus R. And if common ratio is improper fraction, common ratio is more than 1, there are two possible answers. If the first term is positive, then sum of infinite terms is infinity. And if the first term is negative, then the sum of infinite terms will be minus infinity. Let us have a clear example on these three before going to the problems on limits at infinity using GP questions. Question number 4. What is it? There are three sub questions A, B, C. Okay. In each case, limit n approaches infinity only. limit n approaches infinity, limit n approaches infinity. So in the first case, we are taking 1 plus 1 by 2 plus 1 by 2 whole square plus 1 by 2 whole cube and so on plus 1 by 2 whole power n. Limit n approaches infinity, find the answer for this. And in the second case, what we will take is 3 plus 6 plus 12 plus 24 plus and so on plus 3 power n. 3 power n, no, 3 into 2 power n minus 1. 3 into 2 power n minus 1. Okay now. So this is the second function, and in the third function I will take minus 3, minus 6, minus 12, minus 24 and so on, minus 3 into 2 power n minus 1. So what are the answers? In the first one, second one, third one, all these three series are geometric series only. They are under, the terms here are under geometric progression only, correct or not? Because a2 divided by a1 is 1 by 2, a3 divided by a2 is also 1 by 2. So in the first one, a2 by a1 is 1 by 2 divided by 1, so 1 by 2. a3 by a2 is also 1 by 2 whole square divided by 1 by 2, which is also 1 by 2. So therefore a2 by a1 is equal to a3 by a2. It is in GP only. It is in GP only. And observe, what is common ratio? It is a proper fraction, correct or not? So this is sum of infinite terms, because n approaches infinity, it is sum of infinite terms in GP. So the answer is a by 1 minus r. A is the first term, which is 1 divided by 1 minus, the common ratio is 1 by 2, and 1 divided by 1 by 2 will be 2. So that is the answer, dear students, for the first question. The answer is 2. Indirectly it is sum of infinite terms only. Okay, now let us look at second question. 3 plus 6 plus 12 plus 24 and so on, it keeps going until how many number of terms? Infinite number of terms, until 2 power infinity. That means there are infinite number of terms, and all are positive terms, all are increasing, correct or not? What is the answer? Infinity. And in this case, negative numbers are increasing in magnitude, correct or not? Minus 3, minus 6, minus 12, minus 24 and so on. How many number of terms? N approaches what? Infinity, na? There are infinite number of terms, all are negative and they are increasing in magnitude. If you add this, what will you get? Minus infinity. Okay, so I hope you got clarity in this particular concept. Now let us solve two questions based on this. So fifth question, n approaches infinity, numerator by denominator. Obviously, dear students, the numerator is sum of infinite terms and denominator is also sum of infinite terms. And in numerator, what is common ratio? 1 by 2. In denominator, what is common ratio? 1 by 5. I hope you know already how to find the common ratio. Second term by first term will give you common ratio in numerator and also in denominator. Now, the common ratio in numerator is a proper fraction. So what is sum of infinite terms? Because n approaches infinity, na, the numerator is sum of infinite terms in GP. So the formula is a by 1 minus r. Correct or not? A is 1, a by 1 minus, common ratio is 1 by 2. Divided by, in denominator also the common ratio is a proper fraction. So here also a by 1 minus r. So what is the answer, dear students? The numerator will become 2. The denominator will become what? 1 divided by 4 by 5. It is 5 by 4. So 2 divided by 5 by 4 means 2 into 4 by 5. Correct or not? So the answer is 8 by 5. The answer for this question is 8 by 5. Okay, next question. Here is our next question. The numerator is 1 plus 5 square and so on up to 5 power n. And the denominator is 1 plus 3 square and so on up to 3 power n, where n approaches infinity. The numerator is a GP whose common ratio is second term by first term, which is 5. And the denominator is also a GP whose common ratio is second term by first term, which is 3. Both the common ratios are greater than 1. So what is the sum of n terms? First of all, sum of n terms is equal to, if you want to write, you can write infinity. The numerator is what? Infinity, divided by denominator is also what? Infinity. So you are actually getting what model? Infinity by infinity model. That does not mean that I will write the answer as infinity by infinity, na? Let us see what is the answer. To answer this, first of all, let us use sum of n terms formula. it is a into r power n minus 1 by r minus 1 if r is improper fraction. Correct or not? This is the formula to find sum of n terms. So therefore it is equal to limit n approaches infinity. So a is 1 into common ratio is 5 power n means number of terms, power 5 power 0, 5 power 1, 5 power 2 and so on 5 power n. It is not n terms, it is n plus 1 terms. 1, 2, 3 and so on n terms including the first one. So n plus 1 terms. So 1 into 5 power n plus 1 minus 1. So what is it? A into r common ratio power number of terms minus 1 divided by r minus 1. That is the numerator's value divided by, similarly here also a into common ratio power number of terms minus 1 divided by r minus 1. Be careful when it comes to number of terms. It is n plus 1 terms in the numerator, n plus 1 terms in the denominator. Okay now, so it is equal to limit n approaches infinity 5 power n plus 1 minus 1 by 3 power n plus 1 minus 1. What happened to by 4 and by 2? Obviously they'll get cancelled now. You'll get into 1 by 2. Okay now, by 4 by 2 they'll get cancelled. You'll get into 1 by 2. Take it outside the limit. Now you know what to do, what to divide in numerator and denominator. You know it very well. With what we will divide here, students? Obviously with 5 power n plus 1 only na, to get proper fraction. So which is equal to 1 by 2 into limit n approaches infinity. Divide numerator and denominator with 5 power n plus 1. So you will get, I am writing it directly, 1 minus 1 by 5 power n plus 1 whole divided by 3 by 5 whole power n plus 1 minus 1 divided by 5 whole power n plus 1. So now as n approaches infinity, this will be 0 because it becomes proper fraction power infinity. This is 0, this is also 0. It looks like 1 by 2 into 1 minus 0 divided by 0 minus 0. But you know the denominator is not exactly 0 minus 0. It is 0 point something minus 0 point something. But you know very well 3 by 5 is greater than 1 by 5. Correct or not? Then this value power infinity will be more than this value power infinity. So this overall subtraction will give you positive 0. Positive 0 means 0.0000 something. So the answer looks like 1 divided by positive infinity, positive 0, which means plus infinity. The answer is what? Plus infinity. So this function value approaches infinity when n approaches infinity. That is the answer. And I'll tell you one thing. If the same question is given like this in the numerator and this in the denominator, then what will be the answer? The reciprocal of this answer. What is reciprocal of infinity? The answer will be 0. So here the answer is infinity, but when will I get answer as 0? If this series is given in the numerator and this series is given in the denominator. Okay now answer the next question. Think well. Try that question, you will get the answer. I'll write the next question on the board. It's you who are supposed to think about it. To answer 7th question, obviously you need the help of 6th question. Think about it, you'll get the answer. So here is our 7th question. You can easily answer the 7th question if you have understood 6th question. Okay now, think about it, solve it and let me know what is the answer for 7th question in the comments. Okay, we'll go with next question. So here is our question number 8. Limit n approaches infinity, n plus 3 factorial plus n plus 1 factorial divided by n plus 3 factorial minus n plus 1 factorial. So you should have the basics of factorials. What is it, dear students? Generally we can say that n factorial is n into its junior. That means what? After n what integer will get? After n means in decreasing order, n into n minus 1 factorial. So n factorial will be n into n minus 1 factorial. Okay now, similarly if you have n plus 1 factorial, I can write it as n plus 1 into its junior. That means n factorial. I can write n plus 2 factorial as what? N plus 2 into its junior, which means n plus 1 factorial. The integer just lesser than 2 plus n plus 2 is n plus 1. And observe one thing, n plus 2 as it is, I can write n plus 1 as n plus 1 into n factorial. Correct or not? We'll use the same concept while solving this question. Limit n approaches infinity, directly if you substitute infinity, n as infinity in the question, you'll get infinity factorial plus infinity factorial by infinity factorial minus infinity factorial. It is in infinity by infinity form. Then how do we solve it? It's very easy, pretty easy, just like this. You write n plus 3 factorial as n plus 3 into its junior n plus 2 into its junior n plus 1 factorial. Why? You will understand. Plus, don't do anything here, write n plus 1 factorial as it is. The same story in the denominator, n plus 3 factorial as n plus 3 into n plus 2 into n plus 1 factorial minus n plus 1 factorial as it is. Now what can I take common in the numerator? That's important. What can I take common in the numerator? N plus 1 factorial can be taken common in the numerator into what is remaining in the first term? N plus 3 into n plus 2. Okay, n plus 3 into n plus 2 plus I took n plus 1 common, n plus 1 factorial common now here and here. We still have plus 1 here. The same story in the denominator also. If you take n plus 1 factorial common, you will get n plus 3 into n plus 2 minus 1. Obviously the factorials get cancelled, n plus 1 factorials. Now you can solve it like the previous question. The numerator is a quadratic polynomial in n. The denominator is also a quadratic polynomial in n, and n approaches infinity. And since the degree of numerator is same as degree of denominator, what is the answer? We discussed in yesterday's video na. What is the answer? Coefficient of n square in the numerator divided by coefficient of n square in the denominator. So n into n is n square, its coefficient is 1 divided by, again n into n is n square, its coefficient is 1. So the answer is 1. We discussed it yesterday. Okay na? So you can go through yesterday's video in case if you have forgot this concept. Fine, we'll go with next question. But this question's answer is what, dear students? Answer is 1. Okay, we'll go with next question. Here is a 9th question, a little bit different model. They told us to find the value of this limit. Okay now, using what theorem? Sandwich theorem. Underline this. That means we will use some inequality to solve this question. Correct? So those who have no idea about sandwich theorem, please check out the video in the playlist of limits chapter. I have explained clearly about sandwich theorem with different examples. Fine, come back to this. This question would have been a easier question, a very basic question if sin x is not there. Instead of sin x, if anything like x or x square or x cube, if something is there, we could have answered it directly. Correct or not? Like we explained it in the previous videos. But because of presence of sin x, what I am going to do and how I am going to answer this question, listen carefully. Easy itself, but I am going to use sandwich theorem. So what kind of inequality we will use? Obviously, sin x is present in the question. Let me use inequality which has sin. What is it? We know that sin x is between minus 1 and plus 1. I am going to use this inequality. Just like that you will get the answer. See, dear students. For sin x the coefficient is 4. So let me multiply with 4 here, here and here. You are multiplying with positive number. Na? Inequalities will not change. So I multiplied with 4. Minus 4 less than or equal to 4 sin x less than or equal to 4. Next, 4 sin x is added to 3x, correct or not? You can add 3x in all these 3 places. Addition or subtraction will not change the inequalities. So 3x minus 4 less than or equal to 3x plus 4 sin x less than or equal to 3x plus 4. Next thing is important. You are going to divide 3x plus 4 sin x with minus 2x plus 15. You are going to divide all these 3 with minus 2x plus 15. But understand, x is approaching infinity. Then minus 2x is approaching minus infinity. Minus infinity plus 15 is minus infinity, which means you are dividing with a negative number which is almost minus infinity. You are dividing with negative number. Understand this. When you are dividing with minus 2x plus 15, here, here and here, you are dividing with the minus infinity. That means a negative number, negative infinity. Since you are dividing with a negative number, inequality will change. What I am dividing, dear students? I am dividing with this. 3x minus 14 divided by minus 2x plus 15 less than or equal to 3x plus 4 sin x divided by, I'm sorry, it is not less than or equal to. I have divided with minus 2x plus 15 in all 3 places. And as I told, what I told here just now, I told that minus 2x plus 15 is a negative number. Why? I just now have explained. X is infinity, x is approaching infinity, minus 2x is approaching minus infinity plus 15 is minus infinity. You are dividing with a negative number, na? So inequality will change. Inequality will change. Now you are supposed to find limit x approaches infinity this function. So apply limit x approaches infinity in all three cases. Limit x approaches infinity this function, limit x approaches infinity this function, and here also limit x approaches infinity this function. These two limits are easy to calculate. That's why we are using sandwich theorems. So you are finding limit of one function whose limit is not so easy to calculate. Okay, not so easy to calculate, but that function is sandwiched between two other functions whose limits are easy to calculate. That's why we are using sandwich theorem. And how can I calculate this limit? The degree of numerator is a polynomial, denominator is a polynomial. Degree of numerator is same as degree of denominator. So what is the answer? X coefficient 3 divided by x coefficient minus 2. Correct or not? Greater than or equal to, this is our question. Greater than or equal to. Here also, polynomial. Degree 1. Degrees are same. So what is the answer? X coefficient by x coefficient 3 by minus 2. Our question is sandwiched between two same numbers 3 by minus 2. Therefore, what is our answer? Our answer is 3 by minus 2 or minus 3 by 2. Our question is sandwiched between two same numbers, na? So our answer is between 3 by minus 2 and 3 by minus 2, which means 3 by minus 2 is our answer. 3 by minus 2 is same as minus 3 by 2. Okay, we'll look at next question. Before going to next question, I hope you understood how I'm solving this question using sandwich theorem. Okay, fine, we'll go with next question. Here is our next question. Observe, limit n approaches infinity, 1 by n power 4 into step of 1 cube into x plus step of 2 cube into x plus step of 3 cube into x and so on. Generally what happens means, when students see the involvement of greatest integer function, they generally will drop the question, they will go to next question. But understand, after seeing the solution, you will say that the solution is very easy. We cannot leave a question which contains step functions because they are very easy to solve. You do as many questions as possible, you will understand it. Okay, come back to this. Let us see how to answer this question. It is not a normal bracket, it is greatest integer function, step function. Okay, now fine. Do you remember the definition of step x? Step x is equal to x minus fractional part of x. We can also say that step of any real number. That means the greatest integer function of x is equal to x minus fractional part of x. Let us use this definition while solving this question. Okay, so limit n approaches infinity, 1 by n power 4 into, but before using this definition, let me write this in summation form so that my solution looks simple and easy. Observe, the first term contains 1 cube, the second term contains 2 cube, 3 cube and so on n cube, or even easier to say 1, 2, 3 and so on, and all the terms contains x with step. Okay, now how will I write this in summation? Sigma r is changing from 1, 2, 3 up to n. R is changing from 1 to n. Sigma. So step of, instead of 1, 2, 3 and so on, I'll write r cube into x. This is how I'll write this entire series in the form of summation. You should understand this. Next what I'll do is I'll use this definition. Limit n approaches infinity, 1 by n power 4 into, open the bracket, sigma r is equal to 1 to n. Instead of step of r cube x, I'll use, what is it? R cube x minus fractional part of r cube x. Why should I write like this? You'll get an idea. Now summation is for both the terms. Summation is not only for this, it is for both the terms. Okay, now separate the summation. Limit n approaches infinity, 1 by n power 4 into, open the brackets, summation for this one. When I give summation for this one, x does not depend on the summation, only r depends on the summation. Since x does not depend on the summation, you can take x out of sigma. Okay, what will you get? Sigma r is equal to 1 to n r cube. Okay, fine. Minus, summation is also for this, sigma r is equal to 1 to n fractional part of r cube x. Close the bracket. We are very close to our answer. I hope you understood up to here. Dear students, What is this expansion? Sigma r is equal to 1 to n r cube means first r value will be 1 cube. Sigma means plus. Next r value will be 2. So 2 cube. Next 3 cube. And so on up to where r value is up to n until n cube. So this is sum of the cubes of first n natural numbers. I hope you remember this formula. It is n square into n plus 1 whole square whole divided by 4. Okay, now so let us substitute it. Limit n approaches infinity, 1 by n power 4 outside into x into n square into n plus 1 whole square by 4. Okay, minus what I'll do is let me write sigma r is equal to 1 to n fractional part of r cube x. Okay, fine. This by n power 4 I will take it inside for these two terms. So when I take by n power 4 inside, so n power 4 will come here and at the same time n power 4 will come in the denominator. Now the decision making step, you have to understand this. Fractional part of a number is always between, what is it? A fractional part of a number is always between 0 and 1, correct or not? Which means it is a proper fraction. It can be 0 also. A fractional part can be 0 also. Dear students, fractional part, in the first term it is fractional part, a number between 0 and 1. When r is equal to 1, if you expand this, actually what will you get? Fractional part plus fractional part plus fractional part and so on only. Now when you expand the numerator using summation, the first one is fractional part which is less than 1. Second one is also fractional part which is less than 1. Third one is also fractional part which is less than 1. You are adding numbers which are proper fractions until n. The sum of all these numbers which are lesser than 1, each one is less than 1 na, each one is less than 1 na, then the sum may not go to infinity. Are you understanding this? The sum will not be infinity. A proper fraction plus proper fraction plus proper fraction and so on up to infinite terms will not be infinity. It will be some finite number. Why the sum of proper fractions will not be infinity means, look at the sum of infinite terms in geometric progression. You will get a by 1 minus r. You will not write infinity as answer, correct or not? For the same reason, finite number plus finite number plus finite number and so on, which are proper fractions. Proper fraction plus proper fraction plus proper fraction and so on up to infinite terms will be some finite number. Therefore, dear students, what you have to understand is that, this is important. The numerator value will be a finite value. But n approaches infinity na, the denominator value is infinite value. And finite value divided by infinite value will be 0. So this entire term becomes 0. That is what you are supposed to understand. Okay, now fine. And here the numerator is a polynomial whose degree is 4. The denominator is also a polynomial whose degree is 4. Okay, now so I'll write the answer directly. What is it? X as it is. It is independent of limit also. The answer is n power 4 coefficient divided by n power 4 coefficient, because n approaches infinity na. So n square into n square coefficient is 1 in the numerator divided by n power 4 coefficient is 4. I wrote it directly. Okay na. So the answer is x by 4. The answer is x by 4. If you are confused in understanding this step na, you are supposed to watch yesterday's video. So when numerator is a polynomial and denominator is a polynomial, how to find the limits at infinity, I explained in the previous video. So here n square into n square coefficient is 1. Here n square into n square means n power 4 coefficient is 1. And here denominator n power 4 coefficient is 4. So we'll take 1 by 4. Limit of this will be 1 by 4. X will be x only. The answer is x by 4. Okay, now I'll give 2 more questions on this particular model. You do it and let me know whether you have got the answer or not. In case if you are feeling troubled, once again watch this particular solution. You will get clarity. Very easy questions ma. I'll give 2 more questions on the same models. You can try it. So 11 and 2 are all solved exactly like the previous question. You will do it. You can do it. There is no doubt in that. And let me know what are the answers for 11th one and 12th one in the comment sections if you have solved it. Okay, we'll go with next question. So here is our next question. It's a very simple question itself, but you should get that idea how to solve. Okay, we will find this particular numerator even in sequence and series and some other topics. Okay, observe how we are adding the numerator. Okay, how we are making it simple. Now listen here. First let me simplify the given question. I can write the entire numerator in summation form as sigma r is equal to 1 to n, because in the first term contains 1, second term contains 2, third term contains 3 and the last term contains n. I'll write it in summation form. Sigma r is equal to 1 to n r into r factorial. So each term looks like r into r factorial. Correct or not? Whole divided by n plus 1 factorial as it is. So limit n approaches infinity. And this is important. This particular step is important. What I'm going to do is I'll write r as r plus 1 minus 1. I will write r as r plus 1 minus 1 into r factorial. The denominator n plus 1 factorial as it is. Next, dear students, what I'll do is I'll multiply this r plus 1 with r factorial minus 1 with r factorial. That is my next step. So limit n approaches infinity, sigma r is equal to 1 to n, r plus 1 into r factorial is r plus 1 factorial according to definition of factorials, minus sigma r is equal to 1 to n, r is equal to 1 to n, 1 into r factorial will be r factorial, whole divided by n plus 1 factorial. Okay, now 1 plus n plus 1 factorial. Now dear students, you can expand the numerator. First of all, let us simplify the numerator. Let us simplify the numerator here. What is the first term? If I write it in full form, first r is equal to 1. If I substitute 1 plus 1 will be 2 factorial plus. Next r value is 2. 2 plus 1 will be 3 factorial. So 2 factorial plus 3 factorial plus 4 factorial and so on up to lastly r value is n. You will get n plus 1 factorial. So this is the expanded form of this one, minus open the bracket. Here we'll start from r is equal to 1 to n. So what is the expanded form of this second term? You'll get 1 factorial plus 2 factorial plus 3 factorial plus and so on plus n minus 1 factorial plus n factorial. That is the expanded form of the second term. Observe 2 factorial minus 2 factorial, 3 factorial minus 3 factorial, 4 factorial minus 4 factorial, and all will get cancelled. Before n plus 1 factorial we have n factorial. Okay, remember this. And plus n factorial minus n factorial. All terms will get cancelled except two terms. N plus 1 factorial in the numerator in the first case minus 1 factorial. These two will not get cancelled. So therefore, dear students, the simplified form of numerator is what? Limit n approaches infinity. The entire numerator after cancellations is n plus 1 factorial minus 1 factorial. 1 factorial is 1. So this is the simplified form of numerator. And the denominator n plus 1 factorial you can separate for both of them. N plus 1 factorial and here also n plus 1 factorial. So next, this will be 1 minus. N approaches infinity na. Infinity factorial is also infinity. 1 divided by infinity will be 0. So what is the answer, dear students? The answer is 1. Okay, so we'll do other problems on limits at infinity in next video. So I hope you have understood all these problems. See, there are different models. I'm trying to cover all possible models in limits at infinity. Okay, so 2 parts are over already in problems on limits at infinity. In next video we'll see part 3, and after that we will go with limits on the form infinity minus infinity. Okay, we will see that in the next video. So this is M. Sandeep Kumar, and I hope you have understood this concept and you have understood how we have solved the problems. So if you have understood it, do like the video, share it to your friends, and if there is any feedback left with you, let me know in the comment sections, and do answer the questions which I have questioned. Okay, try these questions. See you all in the next video. Thank you. Take care.